Hello and welcome back to the development of the Feersum scheming compiler. So rather than continue on with any feature development today, I spent some time at the weekend testing how well the compiler I've been writing can work with other people's test suites, and doing that I found quite a catastrophic bug. So that's what we're going to look at fixing today. But before we get into that, let's go over what we did in the last stream, just so get back up to speed. So this last stream was all about compiler diagnostics, and it would be in the binder. So we spent the stream before looking at emitting diagnostics for syntax errors, and then the last stream was all about semantic errors. So the idea is that in our binder now, as we go through and bind, we have this collection of diagnostics, and every time we want to report an error in the binding, rather than throwing an exception, we now store things onto this diagnostics. So for example here, if we expect an ID, we do diagnostics.emit, and this means that all of the fail with calls inside this class are now things that are problems genuinely with the compiler, not with the code that have been written and trying to be compiled. So we've got a bunch of them because we don't yet support light bindings and those kind of scopes, and there's a whole bunch down here for things like cond and case and or and quote and things, because I haven't got around to doing that as well. The reason being behind all this is that I'd like to get macros and stuff working before I move on to doing things like AND and that kind of thing, because an AND operation in Scheme is quite easy to define as a macro, and be a nice way to test the macro system. Let bindings is the near future, but on to the bug, I guess. So this is this is the issue in the repository. So for this piece of example code, I'm just going to make it a little bit bigger. If we have a function like make counter, the idea of this function is it uses you call it with a given number, and it returns you a function that every time you call it will return you an incrementing number. And then we create two locals from 10 and from ton, which start off at 10 and 100, and then the idea is that by calling them we should see like 11 and 101, but what we actually see is 101 and then 102, because whereas in a normal scheme compiler you'd expect this variable to be closed over by this lambda, this lambda would capture n from the outer environment, which would be the environment of the call to make counter. What's actually happening in the code that we emit is that n is being captured from this scope. So like when we actually define make counter, we create the environment there once, and then when we call make counter here, we hoist the value once, and then when we call make counter again, we hoist the value a second time, but we hoist it back into the same environment. So I'll try and explain that with Sharp Lab. So maybe I won't. It's not loading for some reason. instead, I guess we'll just have to have a look at the code. So the problem is not to do with the bound syntax tree. So in our binder, when we get a lambda, we eventually call bind lambda body, which goes through and works out all the different, it creates the right scopes and then calls bind sequence on the inner body. And this context that we end up with at the end has like environment information that we then return in our bound tree. And in the bound tree for the broken program, here's an example of the broken program, we do actually end up with the correct, what is called free variables of n being free from this expression but not free from this expression. The problem is that when we actually lower that bound lambda in the compiler, we call emit lambda, and in emit lambda we effectively emit lame lambda creates as a pair of functions, one which is the real body of the lambda and one which is a thunk that does some argument packing and unpacking to match the calling convention that this scheme is using. And both of those are attached to an environment. And the problem we've got is that then like they're expecting to be instance methods on an environment if they access methods like read and write from an environment. So, and then down here we create an instance of the environment, but this happens when we emit the lambda rather than when it's called. So the problem there is if you call the same lambda more than once, what's going to happen is that an instance of the lambda will be created and bound to wherever you've stored it, and that instance will already have this environment, and then every time you call it, it's just going to overwrite the values in the environment. So a quick and simple fix for this would be inside emit named lambda we could take advantage of the fact that we've got the thunk declaration, and so when we're creating this pair of methods, the main method that we're actually emitting the body of the lambda into is added to either the environment class or the main program class. So it's either an instance method on the environment or it's a static method on the program, and we do that based on env size. But what we could do is only do it based on the parent environment, not the current environment. And we could then, so that the main method would still be done based on the current environment size, but the thunk would be done based on the parent, and then inside the thunk we could create an instance instead of doing it every time it's called. But then you have a weird disparity that calling through the thunk is slightly different from calling the method directly, and I would like to get to a point in the future where if the compiler can work out from the context in the program that the types already match and the argument count matches, that it wouldn't make a call through the thunk, it would actually just make a direct call to the method. So instead of having to pack everything up into an array and then call into the thunk and then have the thunk unpack from the array, if you, for example, call a function that's expecting two numbers with two numbers, it would just call directly into that. So instead, what I would like to do is subtly change how the environments work. So let's just try SharpLab one last try. Stop playing ball. I know it's wrong. So instead of doing that, let's create a simple .NET command line program so that I can push some C# code around and describe what the problem is and what I want the proposed solution to look like. So in the source directory, environment. I think I'm going to have to restart OmniSharp to get it to load that project. So we should have a new code, hopefully. Right, so the way that our environment is currently working is we have a class environment, and an environment has a public constructor which takes an environment for the parent, and we set a field called parent to be parent, and we initialize an array of locals, or slots, I think is what we call them. So the environment takes an int, which is its size as well. And then we say new object of the size. Close. No. Close enough. And say we had a method, we'll try mimicking what we have here. So we've got the counter method, and in this case counter would be a static method on the program, and counter would do something like new environment with a null parent and the size of 1. Oh no, I know. The problem here is that we're emitting counter also onto the environment, aren't we? Yeah, we must be emitting counter onto the environment. Public object counter int n, and this is effectively doing slots 0 equals n, and then it's returning a new func object of lambda, where lambda is our lambda body. So in this case, public object the lambda will do slot 0 equals slot 0 plus 1. And then it will return slot 0. That's not even quite right for the current broken case. Let's just pretend that we only have integers to deal with for the time being. So at least things type check. But even that's not quite right, because what's happening here is that this is new environment, this 0 dot lambda, and this is parent dot slot 0 parent dot and maybe let's try and 10 equals one dot counter. What we're doing here let's just make all of these types match up so that we can actually start using this. Almost type check? Yeah, it does. So that's effectively the same as that define declaration. Then when we define 10, we're doing counter 10, and then when we do a ton, we're doing counter 100, and then what we're doing is console.writeLine calling 10. And if I try and run this, we'll end up with an issue. I'm just going to check if that's .NET. It is a .NET 5 program. So I need to change my launch JSON. Is it .NET 5 or .NET 5? Oh, it's .NET 5. I'm still not used to .NET 5. So in the debugger, environment test, maybe. Yeah, so what we do is we create 2, and if we have a look, 10 has the target, and the target has, so system func basically has a method and like the this pointer for the method. So in this case, the this pointer is our environment object, which has a parent environment with one slot in it, where the value is already 100 because we've shared it. So this is what our current implementation does, but what we'd like to do instead is move the environment initialization from here into counter. So the first thing to do would be, if we, instead of emitting functions that have got environments as instance methods on the environment, we'd make them static, and then we'd have something like var env equals the new environment. So every time you call counter, it makes a new environment. And then we do env.slots, and then instead it's env.lambda, and we'll just make these public for ease of use at the moment. So we're still doing the hoist in the same place in the counter function, but we're hoisting it into a local variable that is the environment instead. And that was to be env without the underscore. And then in env.lambda, again, the this pointer is now not our environment, but it's actually the parent environment. So in this case, we can just do this. And if I run that, we should get 11 and 101. So it seems simple enough to do this change when we think about the actual types that are involved in .NET, and we get 11 and 101. So it seems simple enough when we think about the types that we've got in .NET, but the tricky thing is going to be doing those same refactorings that I've just done on the C#, but through monosessile. So the first change I think we want to do is, at the moment we've got all of our local variables indexed by this local type in the compiler. So in the compiler we have a where do we have it? So yeah, when we emit load, I think it's called emit load. Emit it's not emit load apparently. Alright, well we got the store, so this will do to explain. Yeah, here's the load. We do read from. So every time we do read from a given storage location, if the storage location is a local, we've got this idea of like indexed locals. We just say load arg and then that index. So that's fine, except for the fact that we've got more variables. For example, right now we use some variables as temporaries, and what happens is that we do actually end up theoretically trashing bits of locals, but you should never see the result. So the first refactor is actually that the context should have an array of variables. So when we start off, when we make a context, we make an emit context. We do that in 2 places. The first one is right down at the bottom where we call we create the root emit context. And we've got the body params, which is the formals, and then we've got the local count. How do we use the local count? We basically add a bunch of variables to the body. What else do we do with local count? I think that's it. So I think what we could do is, instead of looping through like this to create them, we could take an array of locals, and then emit named lambda is called from 2 places. It's called to make the body method, and it's also called to make the actual lambda instances. So what we could do there is we instead of doing the locals count, we'd actually have an array, effectively, of variables that we put onto the context. I'm just checking to see where we actually create the child context. Ah, here it is. So we reset next lambda to 0. We could just oh no, well, we've already added all the variables in order, so we do know that those locals match up. Where else do we call load local? We call it in the thunk for the unpack when we're looping through the arguments. We call it also in the thunk when we're making the parameter list. Oh, wait a second, that was that's still an unpack remainder. When we call write to env, we load local temp. Oh, that writes a given variable to an environment. Okay, so that's fine. And here, where we do read from. And I imagine write to also for a local does store lock at the index. So I think we want to have some kind of like to variable. The idea being that we can keep track of. I don't want to accidentally end up reading and writing from the wrong local variable. So I think the best thing to do is to do that, is to sort this out now. To variable. And we'll do the same thing in read from. We've got this weird arg index function, so I think I'm going to put it up there in the same place. Takes a context and an index, I guess, the same as the arg index, and that would do context dot locals. We'll call local to variable. And we just do context.locals dot and then that index. So we need an array on our emit context of locals, which is going to be variable definitions. What's going on here? Variable definition. We want to do local to variable in this context. Local to variable in this context. And then the remaining problem is creating the initial locals. So we just want locals to be an empty list initially, and then when we copy it, we've got a with expression somewhere where we copy. This turned out to be a really bad way to find it. It was in emit lambda, right? Takes the local count, it did that. Emit name lambda. Where do we do the loop? Here we go. So we could do with making this into a list first. Then so the locals would be, can I do count or something? We've got iter is empty, last, length, map fold. Unfold sounds useful. How do we create this iterator? List examples. Could always just build it up the same way that we are doing right now with the for loop. So we can set like locals to be an empty list, and then we'll create a new variable, add it to the body, and then set locals. If we make locals mutable, we'll set locals to locals. What's going wrong here? Value or constructor locals is not defined, but it kind of looks like it is. Oh, because I'm not immutable, right? Spelling is the source of 98% of my errors. And then once we've got the locals list, we can pass that in with yeah. All good. So let's just try rerunning the tests, and hopefully that should be the first item to check off. This is kind of useful because there are a few places already that we're creating temporary variables. So we want to be able to just have the compiler remit extra temporaries wherever it wants and not have to worry about accidentally using the wrong variable's index. What this should also mean did we do oh no, we did something special for the arguments, because if the environment size was we're using the environment size to try and work out if we're on an instance method or not, because instance methods are arguments start at 1 instead of 0. So I'm tempted to try and do the same thing there as well. So we've got, let's just check the test output. Looks like they all passed. What is the change? We've got environment test thing. We can keep that around for the time being. We've got what did I just... I think I've not fully... So we've got the launch JSON. The solution, a CS proj, and the program that needs to be added as well. And then the changes to the compiler so far, pretty minimal. We've got the locals list. We've got our 2 variable, which we use where we read and write. We start off with an empty list of locals every time we create a new function, and we store the locals on the emit context. Good. So we've got our locals. We'll do parameter as well, I guess. So where we've got add param, we can start off with mutable params, and we will set it here. This isn't very F#, but just gotta live with it sometimes. I don't have the time to work it out. Identify params as reserved for future use. Alright, well, parameters then. So we create all our parameters the same way we always used to, and then when we create our context, we can say parameters is parameters, and we will add a list of parameters, which is parameter definition list, and then that's going to break down here because we need to set parameters to the empty list as well. Right. I don't think any of this actually matters, because I think as soon as we go into emit name lambda, we create a new context. It just needs to be there so that we've got some context for the parent. Okay. An emit named lambda is going to add those parameters. And then we'll do the same thing we did. So instead of just doing this args index kind of like hacky thing, we will do context dot locals dot index to just parameters, and we will call this param2 or arg to param. Convert an argument index for low to a parameter definition. Context this. We should probably write some documentation for this local to variable as well. Convert a local index into a variable definition. Variable definitions can then be used with load arg and load lock store lock. It'll also come in useful because we can start attaching debug metadata to the arguments and the parameters and things. If we get typed information back, then that will be good. Arg to param instead of arg index, and arg to param. And we should probably decide which way we're going with this. I think I kind of prefer the index pipeline approach. So back up here, we should do the same thing. With that all done, I think we're going to commit this as is and check off one thing. One test failed. Something has changed. Parameters.scheme. Well, that sounds worrying. We're getting 90. Well, let's have a think about this. What would we actually expect? So we're calling foo with two things. So foo returns the second thing, which is going to be 456. The order is the wrong way around. we're expecting this to be 4, 5, 6. Well, I mean, it doesn't make sense. Well, I mean, 4, 5, 6 is 256 plus 200, isn't it? So that's why it's 200, because we've overflowed the return value of main. Maybe we should make this a little bit. Let's pick a nicer number. 101. And we'll put a comment in as well. Right. And the problem was the parameters are the wrong way round. I think the simplest solution to this is going to be reversing that list in the... It's because we're building it with a for loop. That should make the test pass again. Well, it'll make it fail with a different return value because we've gone for 101 now. Relying on the overflow behavior is probably not what we should do. No, that's still saying... Oh, the parse result's different, but now it's still saying it's returning 90. Why is that? Is it returning 90 means that it's returning the last parameter instead of the first parameter? Parse difference is fine. This difference is not. Why would it? Where do we use? Do any other load args? We do load arg. few times. 20. It's always capture or environment related though, and we're going via load arg 0 because we're loading this pointer. That is the thunk stuff, so that's fine as well. Thunk stuff, thunk stuff. All this stuff about env size needs to change, but that's in the constructor. Environment. That's the constructor for the environment. And we're back round to the beginning. So that does not make any sense. Why have we got 2 failures? Let's try debugging and find out what the bound tree looks like before the compiler tries to lower it. Something like there would be good enough. Got a bound tree. Let's just print it out here and make this bigger. So the body is store of foo of some lambda, store of bar, and then an application. So bar was the one that had 3 parameters. That's saying load arg0, which was right because it was A. And this one should be saying load arg1 because it was B. So we should pick. So that's looking good so far. So if we go into emit named lambda, let's see how those parameters get built up. So we are in the lambda for script body, parameters is empty. We're in the lambda for script body again. Parameters is still empty. Script body lambda 0. So this is going to be foo. Parameters is still empty. Because we haven't done any of the parameter adding yet. Let's just do list.rev right at the end. It'd be really nice if we didn't have to do this. I'll try and come up with a better solution. So, fingers crossed, we end up with 101. Expecting 2 failures, that's fine. Pass difference, that's fine, and 101. So let's update the snapshots. And check what the changes are. So we've got a change in the compiler for the list reversing. We've got our launch JSON change, we don't need that. We do want the change to the parameters, we want to change the pass, we want to change the output. And then we can commit this. Handle keep stop using arg and local indices directly. These could end up being invalid if we do some funky local stuff for temporaries. Right, and we can get rid of that. So now we've got that all out of the way, we need to have a think about how we lower the environment. So in our binder context, the things we'd need to do are reads and writes from our environment should come from a local. So we'd need a variable definition for our environment. But not everything would have an environment, so let's start off by doing that. So we'd say environment. Well, we've got env size down here, so we'll have this is a variable definition option, and we'll start it off as none, and then in emit name lambda, where we create the child environment, we should also start it off as none. anytime we want to read from we've got this walk capture chain, which we use recursively, and then we use it when we store and load. So write to and read from. So it basically takes a context, does something to get through the capture chain, and then performs this last operation at the end with the variable. So we've got write to env temp and read from env. So I guess the first thing we would do I think we'd have a context, bind a context get environment. So we can have like an ensure environment maybe, or get environment for the current context. And this is going to say match the context environment. If we have one, we just return it. And if we don't, we will make one somehow. So what is an environment? It's a variable definition. And we need a type. It's going to be main module type system. It's going to just be an object. Well, we can do it as we know it's actually it's a core type, isn't it? It's the environment type. So we can define a new variable definition for that. Yeah, we don't need new. So we create a variable definition for the environment. We set the environment, I guess, to that environment variable. I think we might also so we set the environment, we'll need to initialize it, I think. So where do we do create environment? So we'll just call that for the time being. In the current context, and it's going to be option default value 0 and context.env size. So return the variable definition. Environment isn't writable, that's fine. So we create the environment and then we'll do context.il.emit codes.store local rm. So we'll create it, which involves pushing it onto the stack, and then we'll store it into our environment local, which needs to be mutable so that we can set it. Really can't spell mutable. Good. So now what we can do instead of what we do right now, where we're trying to access the environment, we call load arg0. We can call get environment context which is going to give us back what we want to do, context.il.load local emit codes.load local. So we get our environment, we load the local variable that it's been stored into, and then we call walk capture chain there. So that's all good for write to. Read from, again, it's going to do the same thing. Get the environment. So now we won't actually we don't actually need to create the environment. Here, we can just call get environment. And then in create environment, that's going to be the next point. So in create environment, we're checking context.env size. So this is all to do with whether or not we are an instance method or not. So I'm going to go back and have a look at the environment test program. So I think it's to do with what your parent environment size is. No, it's what your environment size is. No, it's your parent's environment size. So this has a parent environment with a size of 0 because it's the program. So that's why this is null when we create the environment. So this is the whole. So that needs fixing up. We could have parent m size, couldn't we? And then we'll start off with parent env size none. And then when we create the copy, env size equals env size, parent env size equals context dot size. So we take a copy of the current environment size, and then I think almost everywhere where we refer to env size, we actually care about the size of the parent environment. So get environment, when we're creating the environment, we want to create it for our size. There we care about the parent env size. Let's start right from the beginning. Env size, yeah. Parent env size, yes. That is actually the environment size because we're creating that environment. Yep, that is our environment size. That's our parent's environment size that we're copying in. We start off with none for both of them. Okay. And then what about emit named lambda? This does some funky stuff with environments as well. So here we've got an environment size, but what we actually care about what we care about here is the parent environment. If our environment has, if we have an environment, then we want to create all of our child lambdas as instance methods on ourself. And then this is the environment size for the child lambda. But emit context is the parent. So here, where we do public or public or static, we want to say if the context or environment size is some, chances of this all working at the end is pretty low. Context and size, then we say if context env size is some, context just gonna go for it. I'm just gonna run the tests. So in theory, we should have done that transformation now, and we should have Made the environment variable. Made the environment a local. Only 2 failures. Not bad. Unfortunately, I think 134 means that it crashed. Capture test kind of makes sense. And it's a fact, which is also another capture based one. So what's gone wrong? Stack trace. Well, we've got a let's just run the compiler and find out what we get. Yeah, capture test, I guess. Project. I need to make like a run script or something. I'm fed up of doing that. Right. And then if I do .NET spec capture test, let's see what we get. Invalid program. Lambda 0 thunk. Fair enough. IL spy. Show me the IL for the previous. And it was lambda 0. Lambda 0 thunk, wasn't it? Script body lambda 0 thunk. It's put a load arg right at the beginning when it didn't need to. Let's go have a look at the other thunk. So we've got lambda 0. Let's go have a look at the ones on the environment itself. Just going to open up the code, the IL in an editor. Even though we're doing it syntax highlighting, it's still at least a little bit nicer. So we've got the cons pair, we've got the environment. So what do our so that's the environment constructor. So lambda 0 is a public instance method. Okay. That looks acceptable. What about the thunk? Why did we? Do I overwrite context? I do. We're going to go with parent context. Or choose our parent size. Fingers crossed. Well, that's not quite worked, has it? Still the artifact and capture test. So just going to get rid of some of these intermediate things, and then we will get the IL from the build from the spec obj, which is spec bin. What does it look like? Lambda 0, thunk, still does load arg 0, fine. And that is load arg 0, load lan. Right, so what's actually going wrong? If I try and run spec bin capture test. XE. Object reference not set to an instance of an object. Where? Lambda 0. Which is here. So it seems like we're doing a whole load of load arg 0 stuff when we should be doing load this is the hoisting. have a look at maybe hoist value. So we read from the original location and write it to the capture. Let's try running the capture test interactively and see what happens. So I think this is going to be kind of like an off by one scope level thing, where we're reading from the right place by the looks of things, but we're not writing back to the capture in the right place. So what are we in? We are we're in lambda 0, which is where we care about. We have no hoisted values yet. And we have just emitted a lambda that captures something. Can I do captured just here? I think this is telling us that we've got a capture. It's going into the environment at index 0. But this needs to go into the child environment. But no, it is our environment. So we need to create the instance. So what goes on? So it doesn't contain the hoisted value. So we do a read from. So when we're doing a read from, the storage is arg0. So we do a load arg. But it does arg to param, which is going to tell us that because we're a static method, that should be load arg0. And then we do write to the capture. So the capture in this case is the environment. And here we just do load arg0. Okay, right, that's what's wrong. So that needs to be get environment. And I guess read from will also do the same thing. Yep. Should have a quick audit of where we call load arg0. We do it there. No, there. Where that is correct because that's creating the Lambda instance by binding it to our environment. That again, binding it, core decals, all good. Create environment, background. Third time lucky. Not quite. So what goes wrong? Lambda 0 is an invalid program. Fair enough. Let's IL spy it and see why. Load null, right, so this is newing up the environment correctly. Then that's not great. The problem here is that where we do get environment, we create this environment, we store it on our context, but we don't make it, we don't put it on our method. Body dot variables. Might be time for our once per stream Visual Studio Code crash. It's not limited to once per stream. I just think I'd be disappointed if it didn't crash. Here we go. Reopen, please. How far away are we? What have you forgotten about? Body dot il. Well. Yep. Add the temp. what we could really do with is like a define temp. So we don't end up making this mistake again. Let temp equals make temp in this context for I think we're going to want the type as well. Temp tie. Yeah, I have to come up with lots of interesting variable names. And then we can say anytime someone does body.variables, so we've got another one down here where we're doing let temp equal make temp. Again, for the objects type. We have I mean we could do it there for the locals, but I think it doesn't really make sense. Unpack remainder again. And get environment. And in get environment, we're not yet. We want to do make temp of the environment type in the current context. What's going wrong here? Yeah. Fair enough. Fourth time lucky, that's the saying, right? I think it's more like first time lucky, since we've just said the VS Code crash. So nope, still failing. Still getting an exception. Got the error code 1 through 4. So let's go and run it again and see why. So .NET spec bin capture test exe. And it's lambda 0 lambda 0. Let's have a look at what capture test actually is, so that we can work it out. So this is going to be lambda 0. This is going to be lambda 0. Lambda 0. So why is that getting a null reference? We'll find out. IL spy for the IL spec bin capture test. Capture test.il, and I'll have a peek of that. And it's going to be body lambda lambda 0, lambda 0. So it's making an empty environment and storing it in its local 0, loading local 0, and loading the parent from it, then loading the slots from that. That looks correct. Because that's trying to load A. And in this case, A is here in the first slot of the parent environment. And we're doing a really awkward way to get through to the parent environment right now, but by creating an environment for this and then looking the parent up from it, which we don't need to do, but it works for the time being. So let's have a look at the body of lambda 0, I guess. What's gone wrong there? So we've got lambda 0, lambda 0, lambda 0, and lambda 0 is thunk. What is happening here? So we're loading arg 0, loading arg 1, getting the length, checking that it's 0, then calling script body lambda 0. Okay, so that looks fine. Is lambda 0 so in script body lambda 0, I'm doing load arg 0, store it into the temporary, make a new environment, load the environment, load the slots field, load our temporary and store it into the slot 0. This is wrong. When we're about to make the environment, this should be load local 1, I think, because that's clearly the temporary we've gone for the environment. So that is some hard-coded load of 0. Yes. Yes, this just needs to be get environment, which I think it did used to be. So we load the environment local. Because we're trying to make it an instance method on our current local environment. You're off by 1. Classic programmer error, asking how old I am. How are the tests doing? 154 tests passed. Astonishing. That means I can give up. So let's go through and have a look at what we have changed. We don't want that shitty IL. Get rid of that. We don't need our launch JSON changes. So we've got an environment type, well, a variable definition where we store our environment when we're emitting. We keep track of the parent environment size as well, because we need to know that for working out whether or not we are an instance method. We've got a make temporary function, which was useful. Then create environment is conditioned based on the parent size, which is correct. So we're using the this pointer to create the child environment only if our parent environment existed. So that's to do with whether or not this is an instance method or not. Could we? I wonder if you could. I wonder if there's something on the IL build that tells you whether or not we're an instance method. Parent. Be really nice if there was. What else we got? The get environment, which makes the environment for us if we don't have one. So the environments are lazily created, which is a nice new feature as well. So we don't just create one up front, and that means that if you had a method that some code paths did capture and others didn't, we wouldn't actually create the environment until you'd gone down a code path that required it. I think. Not sure that's going to be great either, but because I can think of other bugs now where you could have one code path that creates the environment, but then another code path which uses the environment, but the environment hasn't been initialized. Yeah, that's not good. I think the better way is that rather than storing that on the, it's because we've got the immutable emit context. So the fix for that is that get environment really we should pass something down, or start mutating the environment on the emit context, and it's basically create a new emit context or something. So if you have an if expression or something, we would the same thing happens with hoists as well, but we'll leave that be for the time being. Yeah, if we've got an environment size, then load the environment, create an instance method. And named lambda. It's all to do with instance methods, parent environment stuff again, all looking good. Right. Move events to locals. Are the child lambdas that capture from that environment, rather than being the parent lambda which originally owned, which first owned So now we got that, we should be able to quickly write a spec test for to prove that the bug is fixed. So I'm going to go find the bug again. I mean, it's not that difficult. There is only one issue. But let's what was the issue called? Issue 4. Get 2 failures now because we don't have any snapshots for it yet, but let's try running it just to be sure things are working. Spec bin issue 4 11 114. Good, at least that is fixed. So we'll create the snapshots for that. Auto-generated 0. Why does it think the... Oh, it's because it's display. Let's return something meaningful, because we actually validate what the return value is. So if we make the body of the method return something that should break if what we've just fixed breaks again, hopefully we don't get into this situation. Yeah, a bunch of extra code, sure. And 116, which sounds about right. And the actual source code itself. Add test for issue 4. I'll say it fixes 4. I mean, the previous commit really fixed for, but there we go. And that is stop sharing the environments. So that's where I'm going to wrap it up today. We've successfully fixed the bug. Environments are no longer shared between multiple calls to methods. It was kind of a silly issue in the first place. It was an implementation mistake, but it's fixed now, and hopefully with the environment stuff normalized and better use of like temporary variables and stuff, we should be able to write code that uses temporaries more easily. And I'll also look at refactoring the environment, because at the moment we've just got one type with a slots array. It'd be nice if we created a new environment type for each lambda that's got captures, and then stored each thing on a field instead. Then we'd be able to like if we've got a parent environment, we'd be able to look things up from there with just a load field. And there's another really awkward code path where we'll try and look something up from the parent environment. We will create our local environment and then look the parent environment up from that, which is kind of needless. So we can probably do a better job in the compiler where we're trying to load a capture chain. We can match that specific case of we just want to look up the parent. Instead of creating a new environment and then getting the parent off it, we can just do load arg0, because we know that's always the parent environment. But anyway, that's enough for the time being. I hope you enjoyed it, and I will see you next time.